Mars and the broader NASA International Space Station program and the other centers that have chipped in to help us get to this point. Thanks very much. And I also want to thank our legislators and government leaders around the mid-Atlantic states that have helped us achieve this also. They've been a key element in keeping it going and keeping it funded and keeping the support there. So my thanks to all of you. And with that, I'm going to turn it over to our program manager, Mike Pinkston, who used to have short blonde hair, but we've really worn him down the last few months.
It didn't take long, did it?
And Mike's done a great job with his team. They've been working really hard, including the last 24 hours, and getting ready to go. So, okay. Mike.
All right. Well, good afternoon, and thanks to all for coming out to what ought to be a good show tomorrow. I've got a few view graphs, if we could bring them up, to kind of walk us through the A1 mission and configuration of the Antares launch vehicle. Next slide, please. Okay, as you may have gathered, the primary objective of the A1 mission is really to provide a risk reduction for a demonstration of the launch vehicle capability itself prior to our first cargo delivery mission to the space station in our COTS demonstration mission. That objective is being achieved by designing an A1 mission in really all regards that is intended to be directly representative of what we're going to do on the COTS demonstration. The launch vehicle configuration is obviously the start. We also are carrying on board a mass representative Cygnus simulator that represents mass properties, the volumetric size of the spacecraft, as well as the direct mechanical interfaces. We will also be carrying on board that payload simulator an instrumentation suite that will be used to gather dynamic environments data that we can use to validate models and ensure that we know going into the demo mission what the Cygnus spacecraft will actually see in flight. Obviously, the orbital parameters are set to be identical to what we're going to be flying on the demo mission, and then all of the integration and launch operations have been scripted in order to emulate the flow that will take place when we've got a live Cygnus on board. The objectives, maybe more specifically of the mission, is to give you some things to look for, the things that we'll be looking for to achieve out of the mission. First, on launch day, the commodity loading and countdown operation to launch. As Frank mentioned, it's about an 8-hour operation from the time we get our team on station through the checkout of all of the subsystems on board the rocket. Then we fuel the rocket and then enter a terminal count to launch. That'll all be conducted as it would be on the demonstration mission. Once we leave the pad, we'll be looking at the stage 1 flyout, including the performance, looking for nominal performance of the engine, core, and thrust vector control subsystems. After stage 1 burns out, about 4 minutes after ignition, we will separate the stage. It's actually a series of separation events where we'll separate the first stage. We'll separate the fairing, and then we'll separate the interstage that holds the second stage to the first stage, ignite the second stage. It'll fly. We'll look at its performance as well as the performance of its thrust vector control system. And then once we're in orbit, we will separate the payload. So that's kind of it in a nutshell. If we could go to the next chart, just a few, I guess, important facts about the mission. It is an Antares 110 configuration. That's our standard first stage, a Castor 30 second stage, and then the no third stage. It is, as mentioned, a 3,800 kilogram Cygnus payload simulator flying out of the Mars Pad 0A. At the Wallops is obviously the lead range. Launch date tomorrow, and our launch window currently is 5 p.m. to 8 p.m. local. We will make a decision tonight after we get our last weather briefing on where to target. We can actually target 2 hours within that 3-hour window. So the decision tonight will be made as far as where we're going to go. Unless I see something that surprises me in a weather briefing coming up, my guess is we'll be going for the front end of that target on a 5 o'clock liftoff. The altitude, or the orbit itself, is a 250 by 303 kilometer orbital inclined at 51.64 degrees. And then, as you've heard previously, the time from liftoff through payload separation is about 600 seconds, or about 10 minutes. We do execute a series of collision and contamination avoidance maneuvers once we separate the Cygnus payload simulator, and that will continue on for another 500 plus seconds. But essentially, that'll take us to our nominal end emission around 1124 seconds. If you go to the next chart, please. This is a graphical representation of the flyout events, along with a timeline down in the bottom right-hand corner. The flyout events are essentially as I've previously described. We've got about a 4-minute first stage burn, at which point we'll cut the first stage engines off. There's a bit of a coast while we separate the stage and the fairing and the interstage, and then we will ignite the Castor 30 second stage, and that burns for about 155 seconds, leading us to an orbit insertion and payload separation at about 603 seconds. See, the next chart is hopefully a brief animation. It'll give you a little bit of a cutaway view of the Antares launch vehicle. Do we have that? Yeah, there you go. So you'll see the AJ-26, dual AJ-26 engines provide the first stage propulsion. They are connected to a pair of propellant tanks. The big blue one is our liquid oxygen tank, and the yellow-colored tank contains RP1 kerosene fuel. The second stage is the Castor 30, and you can see the thrust vector control system situated around the top of the nozzle, along with our orbital-provided avionics system. And then up at the top is a 2-piece fairing that shrouds the payload during atmospheric flight, and then inside that fairing is a Cygnus mass simulator, or on the demo mission, a real Cygnus. So, next chart, please. Providing just a couple of pictures to show you what some of that hardware looked like in the HIF. You can see the Cygnus simulator waiting for the fairing to be mated, and then a picture of the entire launch vehicle being lifted and transferred over to our transporter erector in the horizontal integration facility. And then the last two photos are a couple of pictures from just a couple of weeks ago with the rollout on the morning of Saturday the 6th, followed by the erection to vertical on the launch pad, and that's where we sit today, running through our final last few preparations for launch tomorrow. So with that, that's a brief description, and I think it's range guy.
Yes. Good afternoon. As test director here at NASA's only launch range, I am responsible for ensuring the pathway is clear for the Antares to have a safe flight to space. Early today, our center director granted us the authority to proceed with tomorrow's launch operations, which is the final go for executing our launch plans and the countdown. My first slide, please. From the data and communications perspective, we have assets in Antigua, Bermuda, Coquina, North Carolina, as well as here on the Wallops range supporting the Antares launch. All assets have been configured, tested, and verified ready to support launch operations. At this time, we have approval from all external agencies responsible for controlling the airspace for flyout, and we've issued our standard notices to airmen. I personally like to thank Mr. Ed Gannon from the FAA, Adam Baker from the Joint Space Operations Command, and Ben Nelson from Fleet Forces Vacate for their assistance and responsiveness regarding area clearance. My second slide, please. For mariners, the initial hazard area is an odd shape that extends out about 90 miles. Notice to mariners issued this week request that boaters coming from the north remain north of 37 degrees, 50 minutes, and east of 75 degrees. And those boats traveling from the south remain south of 37 degrees, 20 minutes, and west of 75. Our partnership with the Coast Guard and the Virginia Marine Police will assist us in clearing the area prior to launch. And I personally like to thank all of our area mariners for the support and cooperation. Finally, I'd like to end with our forecast for tomorrow. Currently, the weather officer reports that the winds at T0 will be out of the south between 8 and 13 knots. Visibility would be 7 miles with low-level cloudiness with a slight chance of showers. Putting all that together, it looks like from the T-minus 48 hours, we have about a 45% chance of favorable weather for launch because of the low cloud ceiling and the possibility for precipitation and thunderstorms. On a personal note, for me, this is both exciting, optimistic, nervous, and just ready to execute this mission. I'd like to thank the folks in the field, both at Antigua, Bermuda, and Coquina for their support getting ready for us and all the checkouts and the tremendous work that they've done for us this far. On that note, the NASA Wireless Range is go for supporting tomorrow's launch, and I'll turn it back over to Josh for questions.
Okay. Thank you, John. We're going to start here in the room, and then we'll take some questions from the phone. So let's see. We'll start with Dan, then we'll go down this way. Okay.
Hey guys, thanks for coming down. Thanks for having us again. This is an Alan question, I think. We know that the contracts for cargo delivery will run out and all the flights will hopefully have been successful before the space station is done with its mission. So when do you anticipate you might go about procuring more cargo flights? And do you think that it's credible to have a new participant in this without doing, say, another COTS-like program?
Well, the planning is underway right now to continue the resupply services to the station. I don't have personally the specifics on that, so I'm afraid I won't be able to answer specifically how we would go about it. But definitely the planning is underway so that we would have continuous service of resupply to the space station after these initial contracts run out.
Okay. Tarek?
Thank you. Tarek Malik with Space.com. And I think my question is for the Orbital representatives. You mentioned this is a test flight. You know, that we're going to see how it goes tomorrow. But I'm wondering what your confidence level is based on what you've seen, the work you've done on the vehicle over the last 6 years, of success tomorrow and the ensuing flights later this year. Thanks.
Well, my confidence level is very high. Having watched, I joined Orbital about 5 years ago, and having watched the team work on this, on the development, on the testing that has preceded this, and then having participated in the practices and rehearsals in the control center and watching the Orbital team as well as all the supporting teams work together, I have a lot of confidence that all of that's going to go well. The hardware is ready. It's been through its own testing. And I think that we're going to see a nice show tomorrow, as Mike said. So my confidence is high. I don't know what number you'd put on that, but I feel good about it. Mike, Mike, program manager, how do you feel about it?
Well, we wouldn't be here if we weren't highly confident this thing's ready to go.
That's right.
Hi, Ken Kramer for Universe Today for Frank and the Orbital representative. Since this is an NPLM design, I wonder if you could talk a little bit about the evolved versions of the Cygnus. You brought up in the last briefing about going beyond Earth orbit. I'm also wondering about, you said you could say 30 to 90 days. What about longer term? If you increase the shielding, could this be a permanent addition to the space station?
Well, a lot of things are possible. And, you know, we're really focused on this flight for tomorrow, but looking long term, the Cygnus cargo module is based on the NPLM design built by the same company. The spacecraft itself, however, the service module, is based on our legacy spacecraft with a lot of enhancements to make it more redundant and more reliable. But it is designed for operating in space longer than the current 30-day requirement. And with some additional certification and testing, I feel sure we'd be comfortable going beyond that. And I think, as I mentioned earlier, we probably could go as long as a year if we had the right amount of fuel and did the other certifications necessary for the hardware. That would require a mission. That would require people wanting to use it for that long, and there are folks interested, but we don't have actual customers yet. In terms of using it as a habitation module, we'd have to upgrade a number of things to add redundancy, add shielding, add life support systems, of course.